In this video, we're going to look at cubic functions. This function is a standard form of y is equals to ax cubed plus bx squared plus cx plus d. The significance of a is such that it defines the shape, whether the function is increasing or decreasing. D is the y-intercept. To draw the graph, you need to find the following aspects. The shape. If we're talking about the shape and a is less than 0, or I'm saying a is negative, so the coefficient of x cubed, if it were negative, then the shape of the function is like this, is decreasing. So it starts from the top left, turns at a minimum, turns at a maximum, and continues. If a were negative, this is how the shape would look. If a happened to be positive, greater than 0, meaning the coefficient of x cubed is positive, then the shape starts from the bottom left corner, reaches a maximum, minimum, and continues like that. That is the meaning of shape. And this is decreasing because 2 legs out of 3, it was going down. As x increases, this leg of the graph is going down. Here it changes, starts to go up, turns again, starts to go down. So this is a decreasing function. This is an increasing function. Generally, because 2 legs out of the 3, it's going up. As x is increasing, the y is also increasing. Turns, goes down between the minimum and the maximum and the minimum, then it starts to increase again. That is what governs the shape of the function. The x-intercepts are the 3 points. It should have a maximum of 3 x values where the graph cuts the x-axis. So, if it cuts at those points, that's 1, 2, 3. 3 x values, hence you always see the function with x cubed. It implies that it will be having a maximum of 3 x values, a maximum of 3 x-intercepts. That's the maximum. Sometimes it can have 2. In that scenario where it has 2, one of them is a repeated root. One of them would be a repeated root. A repeated root implies that the graph is an x-intercept as well as a turning point. This means this was an x-intercept as well as a turning point. So this point, whatever it is, will be x plus a squared in the equation. Squared, the squared indicates that it was a repeated root. And to get those x-intercepts, we use algebraic skills or concepts known as the remainder theorem and the factor theorem. The remainder theorem simply talks to long division. We're ensuring that the remainder, when we do long division, using a root into a function, we're going to get a remainder of 0. The factor theorem implies that for a given value of x, if we substitute it into the function of x, we get 0 for the value of y. So, remainder and factor theorem. If given x is equals to k is a factor of f of x, then f of k would be 0. To get the initial factor k, trial and error can be used. Usually the required factor for this syllabus lies between -5 and 5. It's not always strictly whole numbers. It could also be a fraction. But it is within the domain, lies within the domain of x is equals to -5 up to x is equals to 5. It's not strictly in there, but the majority of the questions find their factors within that domain. Now, to use the remainder theorem, we use the root x minus k as a divisor into f of x using long division. The remainder should be 0, and the quotient should be a quadratic expression for which we are well equipped to factorize. To factorize the quadratic expression, you can either use the quadratic equation, the quadratic formula, or you can just use factorization. The two turning points on the graph are known as stationary points. It is stationary within A. Stationary within A. In a physics context, this would make sense because if the first derivative is velocity, then at that point velocity is 0, in which case the object will be at rest. So stationary within A simply means that something had to be equal to 0. In this case, the derivative, the first derivative, f pi x will be equal to 0. The stationary points are at local maximum and a local minimum turning point. The local maximum function changes from being increasing to decreasing, therefore gradient changes from positive to negative. At the local minimum, the function changes from being decreasing to increasing, therefore gradient changes from negative to positive. Then we also need the y-intercept. Well, the y-intercept is this d right here in the function. It's the corresponding d because it's at the point where x is equals to 0. So if we substitute 0 here, there, and there, that leaves y is equals to d. That signifies the y-intercept. The next aspect that we need to delve into is concavity. This entails a point at which the gradient changes from positive to negative and vice versa. So, concavity is the point where the gradient, the actual gradient changes from negative to positive or positive to negative. This signifies the point of inflection. How would you get it? You find a second derivative and you equate it to 0. Find the second derivative and equate it to 0. A function can either be concave up or concave down. If it is concave up, then the second derivative would be greater than 0. If it is concave down, the second derivative is less than 0. Without further ado, we would like to do a question. The first question, we are given an f of x that is equal to negative x cubed plus x squared plus 8x plus 12. Once you're given a question like this, there are a couple of things that you need to be mindful of. A is equals to negative 1. A is the coefficient of x cubed. Since it's negative 1, we expect a decreasing function with the shape like that. Then d is equals to 12. That means the y-intercept is 0 for x and 12 for y. Those are the two most obvious things that we can get there. So 5.1, it says calculate the y-intercept of f. 5.1, y-intercept implies x is equals to 0. X is equals to 0. This implies y is equals to negative 0 cubed plus 0 squared plus 8 times 0 plus 12. Y is equals to 12. Therefore, it is 0 for x and 12 for y. Calculate the x-intercepts of f. Calculate the x-intercepts of f. 5.2 x-intercepts. This implies y is equals to 0. So 0 is equals to negative x cubed plus x squared plus 8x plus 12. We look at the product of this a and this d. We're going to get minus 12. Factors of minus 12. Factors of minus 12 is minus 3, 4, minus 1, 12, 1, 12, minus 2, 6, 2, minus 6, then positive 3, negative 4. If we substitute one pair of these, we are going to get a corresponding factor. So we will start with, let me start with f of 2, positive 2. This is going to be negative 2 cubed plus 4 plus 16 plus 12. This is not going to work out. We are going to get 20, 32, so 24. This is not equal to 0. Therefore, x equal to 2 is not a factor. F equal to 2 is not a factor. F equal to 2 is not a factor. Therefore, we're using the factor theorem right there. Going on to another one. Another one we can take could be minus 1 or positive or negative 2. Let me attempt it. Minus 1, 1. So, for the next one, using the calculator that is required has got an option of equation. If we use that calculator, the first one I'm going to get, it's not even a whole number. So 0 is equal to negative x cubed plus x squared plus 8x plus 12. Then from there, 0 is equals to x minus 3.87. Then the others, if we find that factor, then we do long division. We're going to get 2 that you can't even factorize. So it's negative x. Better yet, let me start by removing the negative. If I remove the negative, 0 is equals to minus x cubed plus x squared plus 8x minus plus 12. Divide both sides by a negative or even multiply. You're going to get 0 is equals to x cubed minus x squared minus 8x minus 12. 1. X is equals to 3.89. This is the only real solution. The only real solution. The other two solutions are non-real. Determine the turning point of f. Turning point, at the turning point the graph is going to, the derivative is going to be 0. So 5.3 f of x is equals to minus x cubed plus x squared plus 8x plus 12. F prime is equals to minus 3x squared plus 2x plus 8. This will be equal to 0. This is a quadratic equation. And in this quadratic equation, if we factorize that, x is equals to 2 and x is equals to negative 4 over 3. How would you use the remainder theorem? That is the point I'm trying to get at. So you take one of these, you're going to get x is equals to 2 is a factor. How do you verify that it is a factor? You're going to say f of 2. You're going to get minus 2 cubed. So minus 3 times 2 squared plus 2 times 2 plus 8. Then from there, we're going to get 0. Therefore, it is a factor. If it is a factor, thereafter, we're going to then say x minus 2 divided into that using remainder theorem plus 2x plus 8. X into 3 steps. We follow 3 key steps. The first step is division. Step number 1, divide the x. Step number 2, back multiply everything. Step number 3, subtract, brackets, and subtract. Do the brackets and subtract. So step number 1, divide the x. This is going to be minus 3x squared minus 3x. Thereafter, back multiply step number 2. Step number 1, divide the x. You're going to get negative 3x. Back multiply step number 2, which is minus 3x squared plus 6x. Put brackets and subtract step number 3. Minus 3x squared minus 3x squared. You should always get a leading 0. That's the first thing that indicates that you're on the right point, or you're in the right direction. Then 2x minus 6x. You're going to get minus 4x. This 2x here minus the 6x, you're going to get minus 4x. Then you go back to step number 1, divide the x. The division is now happening at the bottom there. X into that, you will get minus 4. Then step number 2, back multiply this by that, minus 4x. This multiplied by that is plus 8. Pull down the positive 8. When you pull down the positive 8, step number 3, brackets and subtract. Minus 4x minus minus 4x. 8 minus 8, 0. This is a combination of the factor theorem as well as the remainder theorem. That's how you use that. And once you get the 1, the other is going to be minus 3x minus 4x is equals to 0, minus 3x is equals to 4, x was equal to minus 4 over 3. That's how you get the second x value. That's how you get the second x value. So it's a combination of factor theorem here and remainder theorem down here. Sketch the graph of f showing clearly all the x, the intercepts with the x's and the turning points. Because we got one real root, the other 2 were imaginary. Imaginary simply means the graph was floating. The graph was not touching the x-axis at the other 2. So, to sketch the graph as accurately as we can, the x-intercept, the first one was 3.89. Then the y-intercept was here at 12. Then the turning point, there was one at 2. Let me make space so that it fits nicely. 2, 3.89. Then the other turning point was at negative 4 over 3. The shape that we anticipate of the graph is going to be like this. So there is a minimum at, there's going to be a minimum at negative 4.3, and it's not in connection with the x-axis because that's where there were two non-real x values. Then it reaches a maximum at 2, then comes down to cut there. This is the graph. This is the graph of f. So you have to show the y-intercept. Then at this value, you have to show there was a turning point. At that value, there is also a turning point. Then this is an x-intercept. This is the graph of f. This is the graph of f as accurately as we can do it. That answers question 5.4. Clearly show all x-intercepts with the axis and the turning point. The turning point here is a turning point there, then the x-intercept at 3.89. Write down the coordinates, the x-coordinate of the point of inflection. Write down the x-coordinate of the point of inflection. There are two ways to do it. I'm going to show you both of them. Point of inflection, you differentiate the first time, you get negative 3x squared plus 2x plus 8. You differentiate the second time, you're going to get a linear function minus 6x plus 2. You equate this to 0, therefore minus 6x plus 2 is equals to 0. X is going to be 1 over 3. This is you using the calculus point. However, the point of inflection is also the midpoint between the maximum and the minimum. The point of inflection is also the midpoint between the maximum and the minimum. So point of inflection is equal to x maximum plus x minimum divided by 2. Here they just wanted the x coordinate. Thereafter, x at a maximum was 2, x at a minimum was negative 4 over 3. Then we divide by 2. We're going to get 2 over 3 divided by 2. Final answer 1/3. Here I'm using analytical methods. Here I'm using calculus methods. Whichever you choose, this will always work. Whichever way you choose. Lastly, they want us to do a transformation. Write down the coordinates of the turning point of h of x. The coordinates of the turning point of h of x. H of x is equals to f of x minus 3. So what has happened there? You don't need to get the new equation. What we know for a fact is that the value, the y-coordinate at the turning points has been changed by a factor of 3. 3 units going down. So f of negative 4 over 3. Let me calculate that. Plus negative 4 over 3 squared plus 8 negative 4 over 3 plus 12. The y value of this one was 148 over 27, which simplifies in decimal to be 5.48. Therefore, the first of those is going to be negative 4 over 3, then 5.48 minus 3, because here you have shifted it 3 units down. Therefore, the new turning point, the x-coordinate is still the same, but the y-coordinate is now 2.48. That is the y-coordinate of the first one. Of the second one, let's do the same thing. Negative 2 cubed plus 2 squared plus 16 plus 12. That will give us 24. So f of 2 was equal to 24. Therefore, the turning point is 24 minus 3, which is equal to 2 and 21. Because in this instance, h of x is nearly the graph of f shifted 3 units down. So the turning point here was negative 4 over 3 and 5.48. Here the turning point was 2 and 24. The new graph has simply been shifted 3 units down. So if it's been shifted 3 units down, this is the new graph. And this turning point is negative 4 over 3 and 2.48. The y-intercept is no longer 12, it's now 9. And this turning point is 2 and 21. This purple graph is h of x, and the black graph is the original graph of f. That was the first question there. So what did the question focus on? Do you know how to get the y-intercept? Make x equal to 0 in the function. Do you know how to get the x-intercepts? Make f of x equal to 0, then you find the values of x. Determine the turning point. You have to differentiate. First derivative, then you equate to 0. Sketching the graph, make sure you get the shape right. Make sure you get the coordinates of the turning points, x-intercepts, y-intercepts right. Point of inflection, do you know that the point of inflection is the second derivative equal to 0? Or do you know that the point of inflection is the midpoint between the maximum and the minimum? That's what it's demonstrating there. Lastly, when we do transformation, if they say f of x minus 3, they're merely shifting the graph 3 units down. And how does that affect the turning point? In this case, the y coordinate decreases, or you subtract 3 from it. That's what we did. The original y coordinate was 5.3, 5.48. After we subtract 3, it becomes 2.48. Here the original was 24. After we subtract 3, it became 21. It also affects the y-intercept, which was originally 12. Now it's 9. That is what the question was focusing on. Let's proceed to another question. Unlike in the first question, the second question gives us a graph. And we now have to do graph interpretation. We are working backwards somewhat. The graphs of f of x is equals to minus x cubed plus 3x squared plus 9x minus 27. And a linear function g of x, tx plus q are sketched below. We are given some points, we're given the x-intercepts. A is minus 3 and 0 and B is 3 and 0. C is the y-intercept, we're not given the coordinates. The turning points of f are just stated to be B and D. G and F intersect, they cut each other at E as well as at B. Let me just write down the equations, then I quickly sketch the graph. Minus x cubed plus 3x squared plus 9x minus 27. G of x is stated to be tx plus q. We have A minus 3 and 0, and B is 3 and 0. These are the x-intercepts. They also intersect at a point E, which is minus 2 and minus 10, as well as B. So 2 points of intersection. Because A is negative, we anticipate that the graph will have a decreasing shape. That is true. And then because we see the D, the standard form of the equation is minus 27, that means the coordinates of C are 0 and 27. Determine the equation of G. The equation of G, we first have to get the gradient between point E and B, because those are the 2 points on the graph. Point E and B, gradient is going to be minus 10 minus 0. Minus 2 minus 3. Final answer, minus 10 divided by minus 5, which is just 2. It makes sense because the graph is leaning to the right. That means it had a positive gradient. So g of x is equals to 2x plus q. To get the q, I just substitute 1 point. I'm going to substitute b, which is 0, is equal to 2 times 3 plus q. then minus 6 is equals to q. Therefore, the equation of g of x is equals to 2x minus 6. 2x minus 6. That is the first part of the question. Determine the coordinates of D, the turning point of F. The graph has got two turning points. One of them is already B, so we need to find the one that is happening in D. You differentiate, and you're going to get minus 3x squared plus 6x plus 9. You make this equal to 0. Minus 3x squared plus 6x plus 9. Then we factorize that. The first solution is obviously x is equals to 3, which is a B. We know that should be a turning point. The second one is x is equals to minus 1. This is at B, this is at D. So we need the y coordinate as well. So we're going to say f of minus 1. This is minus 1 cubed plus 3 minus 1 squared plus 9 times minus 1 minus 27. Minus 27, this is going to be 1 plus 3 minus 9 minus 27. This is minus 36 plus 4, that is minus 32. So the coordinates at D, its x is minus 1, but its y is minus 32. Those are the coordinates at D. How did we get it? We differentiated once, equated to 0. We got two values of x. One is at x is equals to 3, which corresponds to the turning point at B. And the other one is x is equals to minus 1, which can only be at D. After we got the x coordinate, we substituted into the function, the original function, f of x. So wherever there was x in f of x, I substituted minus 1. Then the corresponding value we get is 32. Find for which values of x is f concave up. Is f concave up. Here I would like to connect two concepts. Concavity depends on the point of inflection. So if we were to sketch this graph, the graph of f of x, f prime x is equals to minus 3x squared plus 6x plus 9. Sketching it would need a point where x is equals to minus 1 and a point where x is equals to 3. The graph would look like this. It's not a smiling graph, it's a frowning graph because its a was negative. Because a was negative. And its turning point is the midpoint between minus 1 and 3. So minus 1 plus 3, you get 2 divided by 2. This would correspond to 1. Because the parabolic function is symmetrical. Thereafter, this is the point of inflection. Point of inflection. So the question asked, for which value or values of x is the graph concave up? Concave up means the function was increasing. Which function? F prime x. So it was increasing for x less than 1. So concave up, it's x less than 1. And concave down, the function starts to decrease after 1, so it will be x greater than 1. What about at x equal to 1? At x equal to 1, the graph is neither increasing nor decreasing. At x equal to 1, the graph is neither increasing nor decreasing. Determine the values of x. Determine for which values of x is mn a minimum MN is a vertical distance between the two. MN is a vertical distance between the two. And if it's a distance, here we're using functions. The function that is on top is g. So we say Mn is equals to g of x minus f of x. G of x, we said it was 2x minus 6. And f of x is minus x cubed plus 3x squared plus 9x minus 27. This is going to be x cubed minus 3x squared. This is going to be minus 9, so minus 7x. This is positive 27 minus 6 plus 21. This is Mn. This is the function that defines the distance Mn, the vertical distance Mn. Now they want the values of x for which Mn is the maximum. So I differentiate the function. Mn prime is equals to 3x squared minus 6x minus 7. I equate this to 0. 0 is equals to 3x squared minus 6x minus 7. X is equal to 2.83 or x is equals to negative 0.83. Those are the x values. And we knew the turning point was in D and Mn, the minimum value of that distance there. The maximum it can get was if x was equals to 2.83. 2.83, that would be on this side, which would give a minimum, and this one would give a maximum here at negative 0.83. So that satisfies the solution if M is a point and is parallel to the y-axis. So this can only happen at x is equals to minus 0.83. This one, it would ensure a maximum. So we disqualify it. It's a solution, but we call it not applicable. And how do we know that it is negative 8.3 without looking at the function? We do the second derivative test. The second derivative test means you differentiate twice. If you differentiate twice for a certain x and you get a solution greater than 0, that means you're looking at a minimum. If you differentiate twice and you substitute a second x and you get a negative value, you are looking at a maximum. So, differentiating f double prime and substituting negative 0.83, f double prime this function, we differentiate it again. This is 6 negative 0.83 minus 6. 6 times negative 0.83 minus 6. I'm going to get negative 11. Because I got a negative that corresponds to a maximum. Therefore, this is at the maximum. And this one will be at a minimum. That's why we say it's not applicable. This one does not answer the question. 2.83 will not answer the question. Write down the coordinates of the turning point. We're shifting the graph down. Prior to this, B was a turning point with coordinates 3 and 0. And D was a turning point with x equal to minus 1 and minus 32. Then they say there's a function f of x, h of x, which is f of x minus 3. The coordinates, which I'm now calling b prime, would be 3 and minus 3, and d prime, which would be minus 1 and minus 35, because we've simply shifted the graph 3 units down. Determine the equation of the tangent of the, you determine the equation of the tangent of f at x is equals to 1. Tangent implies that you differentiate and get the gradient of that graph. First off, we have to get f of 1. F of 1 would have been minus 1 plus 3 plus 9 minus 27. 12 minus 16. So we're dealing with the point where x is 1, but y is minus 16. Then f prime of 1 is equals to minus 3, 1 squared, plus 6 times 1, plus 9. The gradient at this point is going to be minus 3, plus 6, plus 9. This is going to be 12. The gradient of the tangent is going to be a positive 12. So y is equals to 12x plus c. To get the corresponding c, substitute that point there. Minus 16 is equals to 12 plus c. C is equals to minus 28. Therefore, the equation of the tangent is 12x minus 28. The equation of the tangent is 12x minus 28. Explain the significance of the point of inflection. At the point of inflection, the gradient of the function changes. That is where the gradient of the function changes from either negative to positive or positive to negative. So the most important thing is at point of inflection, number 1, f double prime of x equal to 0. What is the meaning of that? The gradient changes. So there's a rate of change itself. And when I say rate of change, the change I speak of is the gradient. So the gradient is the one that changes from positive to negative. In the context of this question, prior to x is equals to 1, the point of inflection, the gradient was strictly increasing. Thereafter, the point of inflection, the gradient is now strictly decreasing. Determine the value or values of p for which f of x will have only one real root. Only one real root. This is more analytical. And when they say real root here, do not think in terms of nature of roots. Do not think in terms of nature of roots, because that would be a misconception. Instead, you have to analyze the function as it was given. When they say roots, they're talking about the x-intercepts. So the function we're looking at is this one. It had exactly 2 x-intercepts. One was repeated and the other one was happening at, they said A was minus 3 and this was at 3. They are saying, the question says, determine the value or values of P for which f of x is equals to P will have one real root. As soon as you shift the graph down, if you shift the graph down slightly, then you're going to have a scenario whereby the function now has distinctly one real root. one real root, this one only. It no longer has, but since it was sitting on the x-axis, then if p f of x is equals to p, if p is strictly greater than 0, p is greater than 0, then the function is exactly one real root. Why is that so? Because this is a vertical transformation. So when you say f of x, then you say minus p, you are shifting the graph down because of the negative. So the graph is going down, in which case it only takes for p to be anything greater than 0, even the smallest fraction, so long as it's a downward transformation, the graph is going to have exactly one real root, which is that one there. That is what this concept is about. In some instances, the concept looks at the range of values between the two turning points. In this instance, it was slightly different. Here's another question. The graphs of f of x and g of x are sketched below. A is a repeated root because it's an x-intercept as well as a turning point. Are the x-intercepts of f? The graph of f has turning points at A and B. D, which is 0, 6, is the y-intercept of f. It's also the y-intercept of G. E and D are the points of intersection. In the first instance, they want us to show that A is equals to 2, B is equals to minus 2, C is equals to minus 10, and D is minus 6. How do we do that? We have two x-intercepts. One is repeated. So f of x, which they're saying is a x cubed plus bx squared plus cx plus d. This is the standard form. We need to adapt the standard form to the information that we're given. What information are we given? The x-intercepts. So this is as good as a, then x minus x1, x minus x2, x minus x3. This is the turning point, the x-intercept format. However, one of those x-intercepts is repeated. This is going to be a x minus 1. So x plus 1 squared, because it's also an x-intercept and a turning point. So this is the version in which you put it as a repeated root. Then the last one would have been x minus 3. So y is equals to a x plus 1 squared, x minus 3. We need to solve for a. If we solve for a, we only need to substitute a point on that graph. We are given the point D, which is negative 6 for x, for y, and 0 for x. So this is a 0 plus 1 squared multiplied by 0 minus 3. Final answer, minus 6 is equals to minus 3a. Therefore, a is equal to 2. If you analyze the value of a, you'll see that it makes sense in the context of the question. The function is an increasing function, so its a had to be positive. That is exactly what we're getting. Then thereafter, to get the other values of b, c, d, we have to substitute and expand. Y is now equal to 2, then x plus 1 squared, x minus 3. 2, this is x squared plus 2x plus 1, x minus 3. X cubed plus 2x squared plus x minus 3x squared minus 6x minus 3. 2, collecting like terms in the brackets, x cubed minus x squared minus 5x minus 3. Distributing the 2 inside, we'll get 2x cubed minus 2x squared minus 10x minus 6. Therefore, a is equals to 2, b is equals to minus 2, c is minus 10, and d is minus 6, as was required. That is what was required there. They want us to calculate the coordinates of B. But what is special about B it is the turning point of the function. It is the turning point of the function. So y is equals to 2x cubed minus 2x squared minus 10x minus 6. Differentiate once. If you differentiate once, I'm using a different notation here. I can say y prime or dy dx. It's all the same. 6x squared minus 4x minus 10. Equate that to 0. Because the turning point, the gradient, is equal to 0. At a turning point, the gradient is equal to 0, and y prime is merely a gradient function. X is equal to 5 over 3, or x is equal to minus 1. We know that it can be minus 1 corresponds to A. So at B, its x is equal to 5 over 3. They wanted the coordinates or such. So the corresponding y is equal to 2, 5 over 3 cubed minus 2, 5 over 3 squared minus 10, 5 over 3 minus 6. Its y is going to be 2 times 5 over 3 cubed minus 2, 5 over 3 squared minus 10, 5 over 3, and lastly minus 6. The corresponding y is minus 512 over 27. So the coordinates in B are 5 over 3 for x and negative 512 over 27. And it makes sense because the graph is under the x-axis, the point P is under the x-axis, but in quadrant number 3. In quadrant number 3, y is negative and x is positive. The next question is an analytical question. Needs us to interpret what is going on in the graph. H of x is the vertical distance between g of x and f of x. This is to say h of x is f of x minus g of x. Calculate x such that h of x is a maximum where x is less than 0. So they're saying h of x is the difference between f of x, 2x cubed minus 2x squared minus 10x minus 6 minus g of x. G of x was given as, in brackets, it's a binomial expression, put it in brackets so that you correctly distribute the negative. That means h of x is going to be 2x cubed minus 2x squared minus 10x minus 6x plus 6. H of x is therefore 2x cubed minus 2x squared. This and this are like terms minus 16x. This and that, they cancel. Looking at this, they said they want the distance to be a maximum. So you differentiate it once, and h prime of x is going to be 6x squared minus 4x minus 16. Because we want a maximum, the gradient is to be equal to 0. 6x squared minus 4x minus 16. We should get two solutions. Six minus 4 minus 16. The one x value is 2 and the other is minus 4 over 3. But we're given a restriction. They said x has to be negative. So x is equals to 2 is not applicable. It is disqualified by the restriction where x has to be negative. So the corresponding x value is x is equals to negative 4 over 3. Moving on to the next one. Calculate the x-coordinate of the point where f prime x is a maximum. Calculate the x-coordinate at the point which f prime x is a maximum. F of x is equals to 2x cubed minus 2x squared minus 10x minus 6. At a maximum, f prime x is equals to 6x squared minus 4x minus 10. And this is the derivative. This is the derivative, and that derivative has got two x values. This one is 5 over 3, and the other is x is equals to minus 1. If I sketch it, let's also solve it graphically. Minus 1, and this is 5 over 3. What type of function is this? Calculate the x-coordinate at which of the point at which f prime is a maximum. Thereafter, if it is going to be a maximum, this can only be the midpoint of those two. And that is going to be 1/3. We've solved it graphically as well as algebraically. It's the midpoint between the two x values, between this and that. So x is equals to 5 over 3 minus 1 divided by 2. X is equals to 2/3 divided by 2. X is equals to 5 over 3 minus 1 divided by 2. 2/3 over 3. X is equals to 1/3. Algebra, and here's the application of the calculus.